Stuart Morrison, Managing Director of MEP Technologies. Just handing over to you, Stuart.
Yeah, thanks, Dan. Hi, everyone. Thanks for the opportunity to showcase and share a little bit about what we've got going on at MEP Technologies and how that supports the drive towards net zero and all the other things that are good in the world. Right. Yeah, MEP Technologies has been working with rechargeable battery packs for over 3 decades, as other companies. The company itself was established in 2016, and we work in across many industries, but our main focuses are automotive, e-mobility, and industrial battery pack applications. We call the industrial battery pack applications portable storage, because in most cases the battery itself is not a fixed battery. It tends to be something that's capable of being carried by users. The team here at MEP were involved in the development of the manufacture of the battery pack that originally went into the McLaren P1. So that was a 176 kilowatt hour battery pack that was very, very leading edge back at in the middle of the last decade. We're based at the Mitchell in Scotland Innovation Park. We're in just over 10,000 square feet facilities. And here we engineer or design and test and manufacture battery systems for all of these sorts of applications. To support that, so getting a little bit into the engineering, we work with different types of cell chemistries. So traditional lithium phosphate, high power nanophosphate, and nickel cobalt manganese. These are the main ones that are used in the market at the moment. You heard tell earlier of solid state. We've done limited work with a high temperature solid state battery pack. And we also have done some work with supercapacitors and titanate cells. So there are lots of different types of cell technology that are on the market and evolving at the moment. And as a small niche manufacturer and designer, we tend to get involved in lots of them. One of the more important ones that we see coming along is sodium-ion pouch cells or sodium-ion cells. We were the first in the UK to build and test an automotive grade battery pack made with sodium cells that were manufactured by a company called Ampty Power, who are based in Thurso. So our ethos is to be working with the latest and greatest technologies to provide our customers with something that's leading edge or best in class. Other important technologies we work with, so to support battery packs, joining technologies for the interconnections on the cells, bus bars, both laser welding and high power resistance welding are the main welding technologies of choice. We also work with a variety of different cooling systems to cool the cells, some passive heat sinking, active heat sinking, and liquid cold plates. And to support a lot of our applications, especially the mobility ones, weight is a very key factor in the customer's design. So we work with both carbon fiber and aluminium composites and other types of lightweighting technologies. We do lots of validation work here, probably a little bit too deep for this discussion, but all of our batteries are fully tested and supported by rigorous testing for warranty, and we're very aware of all of the typical processes in the automotive industry, for example. We're members of the Niche Vehicle Network. We've also done a lot of work with the UK Battery Industrialisation Centre, and as mentioned earlier, we have a very close working relationship with Ampty Power. Ampty, for those who don't know, have recently announced that they will be creating a UK, they call it a mega factory, 0.5 gigawatt hour, that will be based here at Mitchell in Scotland Innovation Park. And we're very excited about that news and that the move to the local area. Now, more importantly and more exciting, I suppose, a project showcase. So this section, I'll talk about some of the things that we've been involved in, things that we've got going on. One of our early projects was to redevelop the battery management system for the MODEC low carbon vehicle. Again, a lot of people maybe don't know about MODEC, but they were probably the very first commercial vehicle manufacturer, electric commercial vehicle manufacturer in the world. They were based in Coventry, had started manufacturing these around 2005, 2006. And as in Dundee, MEP Technologies, some of the guys here were involved in the manufacture and supply of those battery packs to the vehicle. Our piece of the story in 2016 was the battery management system had become obsolete, and there were still fleets of these vehicles being used in Rome, Paris, and the south of England. And for these field-based applications, we redeveloped the battery packs to include a new off-the-shelf battery management system. It was a very rewarding piece of work, considering we'd been involved with the company previously. And that battery pack is a 1.4 ton battery pack, and it fits between the chassis rails on the vehicle. So quite a big battery, and it allowed that vehicle to run for about 65 to 70 miles on a daily basis. One of the very early commercial vehicle battery applications. One of our other early gigs was to develop a very lightweight, high energy dense battery pack for a classic Mini retrofit. We see an awful lot of inquiries now regarding battery packs for retrofit applications. And to support that, we've developed a modular, standardized sized module for including in battery pack designs. Back at the time, in 2019, that energy density at pack level was 194 watt-hours per kilogram. To compare, the Nissan Leaf, I think, was 154. So it was a very, very energy dense battery pack at the time. We've done battery packs for e-motorcycles and e-scooters. The two pictures you see on the screen, we manufactured a 4 kilowatt-hour battery pack for those. Not light enough to be portable, so they were fixed to the bike frame, and allowed operation of up to 100 kilometers per hour and distances around the 65 to 70 kilometers. So again, an interesting application. And we see that was about 4 years ago we worked on that one. And we see an awful lot of inquiries nowadays for companies, new start companies and existing companies looking to electrify these sorts of applications, which, as the climate in the UK maybe doesn't support all the time, but certainly can support some of the time. One of the projects we're working on at the moment is a battery pack for a light agricultural vehicle or tractor. The battery pack is a 25 kilowatt battery pack. It's just under 175 kilos in weight, and is capable of supporting continuous use for 4 hours at 18 to 24 kilowatts. The system also supports rapid charging. So the idea being that users of the vehicle can run for the morning, can then put it on rapid charge over lunchtime, and then go out and do another half day's work in the afternoon, and then charge up overnight. So the vehicle supports typical duty cycles and typical usage of in an agricultural environment. That pack also has a refrigerated cooling system, which is quite novel. It's the first one we've worked on, and that allows the battery and the vehicle to be used in hotter climates such as India. And finally, we also are more involved these days in light mobility packs. Some of the applications, golf carts, urban mobility applications. Renault Twizy is one I always quote, but that sort of very light L5 to L7 size vehicle. Last mile delivery vehicles, electric go-karts and other leisure applications, jet skis. We get a variety of inquiries for all these different sort of smaller light battery applications. The key points for a battery design for these: low cost with sliding and latching interfacing to hold them in place. Generally, these battery packs are required to be removable. To support that, along with latching interface, blind mating connectors, and as always, the customer wants very high power, but also high capacity with a very light weight. Lots of exciting types of applications. So we're very lucky to be working in this industry at the moment. And I think that's me. Thanks very much for listening.